Hello everyone, it's Benny, and today we are going to be getting rid of all this temporary bounding sphere nonsense, and we are going to be having truly generic colliders in our physics object, and that is without a doubt an awesome thing to have. Why? Not everything has to be a bounding sphere anymore. Then we can have AABBs, planes, we can have some collider we haven't implemented yet, in whatever combination, orientation, whatever that we want. And it will just work. And that, without a doubt, is awesome. And there's good news. We only need one thing to get there. And that's a collider transform. Some way to say, okay, give me this same collider, but in a new position. And it sounds easy. Unfortunately, that is a lot harder than it sounds. So, let's go ahead and let's get started. So I'm going to start by going to collider.h. This is where we're going to need all that transform nonsense. And to start off, I'm going to include /core/math3d.h. Because, unsurprisingly, to transform a whole bunch of colliders around, we're going to need it to use at least a little bit of 3D math. Nothing fancy, but just some basic stuff. And all we really need here is a function. It's going to be virtual, because every collider is going to implement this a little bit differently. You know, transforming an AABB is a little bit different than transforming a sphere. So, virtual void, and it's transformed. And for now, it's going to take in just const vector 3f for translation. How much we're supposed to move it. And it's not going to be const, actually, despite what I just typed. Here's the thing about this. What would be ideal is if we could somehow return a collider from this. Return, hey, this is a new collider with the new position. That would be ideal. That way we can just generate a new collider in a new position on the fly rather than having to worry about keeping the collider we have properly updated all the time. Unfortunately, there's not a really good way to do that because of the way we're using inheritance. The size of a collider can be different. Bounding sphere isn't as big as a plane. Planes aren't as big as AABBs. So things are different sizes, and because of that, there's just no good way to, return this. So unfortunately, we're going to have to deal with a system where the collider updates itself to the new transformation. And that's going to make things a little bit trickier. That said, if you happen to know a way that you can do it with returning new generic colliders that doesn't involve a truly ridiculous memory allocation nonsense scheme, let me know, because that system really would be better. It's just, I don't know a good way to do it. And I haven't heard of any good ways to do it. So, yeah. But for now, we're going to do it in the slightly more difficult updating thing. So I'm going to create a void transform. It's going to be part of collider. Oh, actually, silly me, I forgot. This is supposed to be, again, a virtual function. Everything implements this a bit different. So we're not going to implement this in collider, actually. We're going to be overriding this in all the subclasses, like bounding sphere. So, in fact, I believe bounding sphere is the only collider we have that's actually, inheriting from collider right now. So this is all we have to do. A virtual void transform. So, how is this going to work? Well, the way this is going to work is, first off, let me actually move to the implementation file. So, in boundingsphere.cpp, where we actually implement it, go ahead and put it in. There, this is what I was trying to do earlier. And here. Now, fortunately for bounding sphere, this is pretty easy. It's exactly what we've been doing in physics object already. So we have the translation. All we have to do is say, okay, imcenter plus equals translation. And what do you know? We're done. We've transformed the bounding sphere. But this is going to make things a little bit tricky, like I've suggested before. Because for, physics object, this means we're going to need to keep track of the old position of the bounding sphere. Because we can't just say, okay, bounding sphere, transform with position. Because no, this is an absolute position in 3D space. We're supposed to be updating the bounding sphere's position based on how much it's moved. So yeah, we're going to need to keep track of like an old position or something here, so that we know how much to update the bounding sphere by, which is one of the many reasons why this is a little bit trickier. So, I'm going to go ahead and actually, yeah, I can go ahead and do this. So, in bounding sphere, not going to be a bounding sphere anymore. We're going to be changing this. What we're going to be doing is, I'm going to start by modifying the temporary code, and then I'm going to generalize it. So, we're going to say bounding sphere dot transform. Now, like I said, we cannot use imposition. So, I'm going to have some vector 3f in old position. And old position's just going to be position to start off with. And what I'm going to do here is, well, I'm going to say, first off, vector 3f difference. This is how much we've moved. Or, yeah, sure, translation amount. How about that? Just because that's a little more consistent with what we have in transform. And that's going to be equal to imposition, whoops, spelled correctly, minus old position. So that's how much we need to move. And now we need to update old position to be equal to imposition, because now we've actually updated it. So we're going to transform with translation. Okay, and I went ahead and fixed a few things off screen. We no longer need the const qualifier for getBounding sphere because, well, now it actually is modifying things like imposition and bounding sphere. So that's no longer const. And in collider.h, our transform, it needs an empty implementation just because, well, it needs some implementation. And there, so now if I build and run, then you'll see, look at that. They're still running into each other and colliding like normal. So our new system is working. We just need to get rid of the temporary code now, which is a lot easier said than done. So no more radius, no more boundings here. It's going to be a collider pointer because we're using general colliders now. Then I'm going to call mCollider. That means for our new function, or our getBounding sphere function, we're going to rename this to getCollider. And it's going to be getCollider arrow transform and return mCollider with sort of a star to dereference it. So there, we're also not going to need the getRadius getter anymore, so I'll get rid of that. And we're also not going to need this part of the constructor anymore, so I'll get rid of that. So, but we are going to need mCollider initialized now. But how are we going to do our constructor? I'm actually going to change this entirely, so I'm going to get rid of all the parameters. And now we're going to take in first off, a collider pointer, collider, and a const vector 3f reference that I am going to call velocity. And this is what we're actually going to take in. So mCollider is going to be collider, mVelocity is going to be velocity, but mPosition is going to be collider get center, and mold position, if I can do it, I actually don't know if it allows me to, but I'm going to initialize that to mPosition. So just copy it. Oh, okay, I didn't know if that would work, but okay, it doesn't, so I'll just use collider get center again. And that's a function we're going to need to implement. So yeah, now I'm going to do a little bit of stuff off screen, so one moment. Okay, I did a few things off screen. First off, I defined the getCenter function because I think you should know how to do that. The only trick here is it's virtual, and I overrode it in bounding sphere with what used to be my getter for the center. So there you go. And the other thing is, we're going to need to delete the collider at some point. So what I did is I included core/reference counter, and I made collider inherit from the reference counter, and initialized that in the constructor. And the way I'm using that is in physicsObject.h. Well, as you see, you have to find a copy constructor and a virtual destructor. And copy constructor just copies all the members, but it adds a reference to the collider. And every time a physics object gets deleted, it removes the reference. And if all the references are gone, well, it deletes the collider. So it's just basic reference counting garbage collection, because I figured that's probably the easiest way to do this right now. Whoops. And yeah, that's really all I did, except I'm in the wrong file now. Yeah, I added some basic reference counting in the copy constructor, and, well, I added the getCenter function. So with that, we can try to build. And no last since change. Okay, sorry about that. So now we have a few errors. And that's okay. Now, first off, should take me to them. Yeah, we don't need getBoundingSphere anymore. Now we're using getCollider. So getCollider.intersect. Yeah, because we're using truly general colliders, which is good. That's exactly what we want to do. And now, yeah, this does mean that it's taking me to a random file which has nothing to do with what we're trying to do. Good job. It does mean we're going to need to change main.cpp a bit. And since this is like example code, I am going to do this off screen, so one moment. Okay, so just to show you what I did, I included boundingsphere.h because, well, now PhysicsObject doesn't include that by default. And I did pretty much what you expect. The PhysicsObject passing in a new bounding sphere, it's allocating a new one because it has to delete it at the end, taking in those variables, and the same velocity as before. Only thing I changed here is I changed the radius of the second bounding sphere to 1. Because now there's really not a good way to go through every object and check its radius, so I'm just passing in 1 for everything now. And other than that, as it turns out, we do need to use the assignment operator in PhysicsObject, so I went ahead and I now have a public assignment operator. It returns a physics object, and note, it is taking a physics object as a parameter. Not a const physics object reference, but a physics object. And the reason is I'm using the copy and swap thing. It's using the copy constructor to copy the physics object to a new one, and then I'm just doing, well, I have a temporary character array, and I'm copying everything in here and just sort of swapping it like that. So yeah, it's a copy and swap. That's how I'm doing it. And whoops. And with that, if you build and run, and yeah, that's okay with me, then you see things are working. You've got 2 smaller spheres now, but collision works just the same. So with all that out of the way, we have finally moved to a general collider system. We can easily add and expand on the system, have new colliders, do new stuff, and etc., etc. So that is great. And in the next video, we're probably going to start working a little bit on collision response, so that we can have a more appropriate response than just, oh, let's invert the velocity. So yeah, that'll be our next goal. So thank you. Hope you enjoyed, hope you learned, and I'll see you then.